Alright, so today we'll take a look at Lewis structures, specifically for ionic compounds. Lewis structures help us to explain bonding theory for ionic and covalent bonds. So we'll take a look today at ionic compounds. With ionic compounds, as a reminder, you have a metal with a nonmetal that will form an ionic bond. The cation is positive, the anion is negative, and that electrostatic attraction between the cation and anion make the ionic bond. When we're drawing Lewis structures for an ionic compound, we are going to first start by drawing the Lewis dot diagram for both of the elements. So we will start by doing magnesium oxide. So we'll draw the Lewis dot diagram for magnesium. So magnesium has 2 valence electrons. And then we'll do the same thing for oxygen. Oxygen has 6 valence electrons. Remember that we fill it in, I go clockwise, and then we don't pair up any electrons until they need to be paired up. Alright, so in the case of magnesium, now magnesium is going to be the cation, and it will lose its electrons to oxygen. So it can lose 2 electrons, and oxygen can gain 2 electrons, so they make a nice pair. So magnesium's electrons will go over to oxygen. And what we do is that we are going to write down both of our ions with the charge. So we have magnesium, 2+, and then we have oxygen. We'll put our anion in brackets. We're going to put our full valence shell, since it gained those 2 electrons from magnesium, and then outside of the brackets we will put the negative charge. Alright, so let's do another example. So if we draw a Lewis structure for sodium bromide, then we are going to have sodium. So we'll start first by drawing the electron dot, or the Lewis dot. So sodium is in the alkali metal group. It has 1 valence electron. And then bromine is going to be in the halogens, and so it has 7. 1, 2, 3, 4, 5, 6, 7. Okay. So sodium can lose 1. Bromine can gain 1. Again, they make a nice pair. So sodium will lose its electron. When we draw the Lewis structure, we'll do sodium plus, and then in brackets we'll put our anion. We'll put it with its full valence shell, and then we'll put a negative sign outside of the brackets. Alright, so let's go ahead and why don't you pause the video and see if you can write or predict the correct chemical formula for what will happen with sodium and sulfur. So with sodium and sulfur, we already have our Lewis dots, and what's going to happen is that sodium is going to want to lose 1. So sodium will lose 1 to sulfur, but that means that sulfur only has 7, so it still needs 1 more. So we'll need another sodium, and that other sodium will give its electron to sulfur. So our formula, which we have predicted in the past anyway, because we have Na plus S2 minus, we would have predicted that the formula was Na2S. When we draw the Lewis structures for this, we would have Na plus, and then we'd have sulfur, which has a full valence shell now, 2 minus, and then we'd have Na plus. Keep in mind that ionic compounds are going to form a lattice, so you're going to have this as one of your formula units, and then you'd have Na plus, S2 minus, in our brackets, Na plus as another formula unit, and that the positives and negatives of the formula units would be attracted to the other positives and negatives. So here's just another example of that. So if we have calcium chloride, again, now we have calcium has 2 valence electrons, whereas chlorine has 7. So calcium can lose 1 of its valence electrons for this chlorine, but then we need another chlorine in order to accept the other electron. And so the other electron will go to the second chlorine, and so we would write both anions and the calcium, and this would be 1 formula unit. And our formula for this would be CaCl2. Alright, so let's go ahead and practice. So go ahead and draw the Lewis structure for potassium chloride. So what you should start with is our Lewis dot diagram for potassium, and then for chlorine, which is a halogen, and so it will have 7 valence electrons. So potassium will give one of its electrons to chlorine. So we'd have potassium plus the anion in brackets as minus, and the formula for this would be KCl. So go ahead and try this one. You can pause the video and then unpause it to see the answer. Okay, so we'll start with our Lewis dot. So we'd have magnesium. It's in the alkaline earth metal, so it has 2 valence electrons, so I'll draw 2 dots. I have nitrogen, which is going to have 5 valence electrons. So what that looks like is that it has 3 unpaired electrons. So magnesium is going to give 2 of its electrons. Where did that electron go? 2 of its electrons to nitrogen. So it gives 1 here and 1 here. Okay. But nitrogen now still has 1 open pair. So that means that we need to add another magnesium. So we have magnesium. It has 2 valence electrons, and it's going to give 1 of its electrons to nitrogen here. And so that nitrogen now is satisfied and it has a full outer shell. But now magnesium still has this 1 valence electron left. So now we're going to have to draw another nitrogen. So then we have nitrogen with 5 valence electrons. And so our magnesium here can give 1 of its valence electrons to the nitrogen here. So that magnesium is happy. But now this nitrogen has 2 electrons that are still empty and still need a pair. And so if we have 1 more magnesium, then we can give 1 valence electron and 1 valence electron. So you could draw this a few ways, but we have magnesium 2 plus would be next to a nitrogen, which will now have a full valence shell and will be 3 minus. And then you'd have your magnesium 2 plus. And then I'm just going to draw down here magnesium 2 plus, and then you'd have nitrogen 3 minus. So this would be a formula unit. Our formula for this would be Mg3N2. Alright, so which nonmetal forms an ionic compound that has the formula Al2x3? So for this, chlorine is going to have 7 valence, so it'll be -1. Sulfur has 6 valence, it'll be -2. Nitrogen has 5 valence, it'll make -3. And then carbon has 4 valence, and so if it was an anion, it would be -4. So the one that works here would be nitrogen because it has a -3 charge.